In this video, I'm going to show you a very simple and short proof of the four-colour theorem, which has been theorised for a couple of hundred years, but wasn't proven until about 1977, and that was only done with the help of a computer and 1,800 or so what they called reducible configurations, which they later reduced to about 1,400, and then in 1996 down to about 633, and they've been going on since with various different computer solutions, but none of them seem to be a simple and clearly obvious solution. So let's see if we've cracked this here today. So here is an image with lots of different shapes and areas, but only four colours are needed to colour every single shape without any two that are connected to each other with a border having the same colour. And the theory states that 4 is the maximum number of colours you need to do this. Sometimes you can use fewer, but 4 is the maximum. So let's take a look, for example, at a map of the United Kingdom. Here are the various counties in, England, Scotland and Wales we're showing here. Now, there's several ways that these could be all coloured in with no more than 4 colours, and here's one of them. So we've used various combinations of yellow, blue, green and red, and that's all we needed. I mean, obviously there's the outside, there's a fifth colour, it's white. We could have got around that in other ways, we could have worked with these colours, but that's not what we're looking at. We're just looking at the country or this particular contiguous landmass here, mostly contiguous. So let's see how this works. Let's begin with a county. Here's a county. I mean, a county could be any size, any shape, but when you look at any kind of shape in a topographical way, you can represent it with a circle. It's as good as any other shape. It could be a square, a rectangle, it could be a pentagon, anything you like, but circle is the simplest form. So here we are. This is a county. Now, what can you do when you abut one county with another, or one country with another? Well, let's start by first of all filling in this one county, and we filled it in red. Now, let's imagine that there's another county completely surrounding it, and we can actually fill the two of these quite simply. Just 2 colours is all we need, one for each county. Let's complicate things a bit more. What if the counties surrounding, there were 2 of them? Well, obviously, one of them's got to be one new colour, and the other one's got to be another new colour. So we've got red for the main county, and then we have a green one and a blue one. What happens if we take this up to 4 counties total? So we have 1 in the middle and 3 on the outside. Well, now we've gone up to 4 colours. Does this keep on going? Are we going to keep having to add colours 5, 6, 7 and 8? Well, no, because watch this. Watch what happens when we go up to 5 counties. That's interesting, isn't it? We're now down to only needing 3 colours, red, green and blue. And there's a very, very simple reason for this. When a county is surrounded by other counties, or when a country or a shape or a pattern, whatever it is, when it's surrounded by an even number, then you only need 3 colours. It's as simple as that. That's all you need, 3 colours. Here's another example. Here's where you have 6, so there are 5 on the outside, and we're back to needing 4 colours to do the map, because clearly you can go blue, green, but if you did either green or blue, 2 of the counties would have the same colour, so you bring in a new one, you bring in the yellow. So let's go back to looking at the 3 colours. So there's, although it's 3 colours, let's just think of the number 2 on the outside. There's an even number of colours on the outside, we only need 3 colours. Here there's an odd number of colours on the outside, so we need 4. Even number of colours, we need 3. Odd number of colours, we need 4. And that's it. It's nearly it. There's one more thing we have to remember. When one county touches another, there's 2 ways it can do it. It can do it with an area of border that is shared, or it can just do it with a point, like a triangle. So let's take an example of that. Here we are. Here we are surrounded with the 3 counties. Let's go back to this map here. We've got the 3 counties on the outside, but they all touch each other. But in the case here, right at the top there is another county coming in, or maybe there's a C or the end of it, but it doesn't matter. Whatever it is, there's something that goes right up to a point, just touching the inner circle with a point, and therefore that acts as another colour all of its own. So therefore we only need the 2 outside colours and the 1 in the middle, 3 colours total. So here's an interesting observation which we can improve our explanation on by doing this. Let's look at where we have counties surrounding an inner county, and they're doing it in the 2 different ways. Some have borders, some of the outsides are touching the inner county with a point. It doesn't matter. If you look at the top, there's a green county. Next to it on the right, there's 2 of them, green and blue. Next to that, there's 3, green, blue, green. Next to that, there's 4, and then 5 as you carry on rotating your viewpoint round the circle. It doesn't matter how many you have in this particular case. You only need 2 additional colours on the outside because of all these pointed triangular breaks where the outside, or if there's a county there, only just touches with a point and doesn't actually share any border with the central object. So these are the simple rules. Let's recap. So for colouring the UK, for example, you could start with a county and fill it in, and then you could have other counties around it, as many as you like. If you have an odd number around it, you're going to need 4 colours. If you have an even number around it, you're going to need 3 colours, and on and on. But if there's any corner bits, any projections of another county, or just an ending of your territory that just touches the county with a point, then you're back to only needing 2 colours on the outside. And that is it, because, and here's the fundamental reason, every single county can be, you could look at any one of the other ones and make that your centre county, and it still has the same properties. It can only be surrounded in 2 ways, with counties that touch and share a border, or with counties that just have a point touching and don't share any border but can act as a divider between other counties. And that is the whole theorem. All you need to know is these few simple patterns, which I'll go through one more time again. You need to know if there's 1 county touching, well, that is a specific case. You only need 2 colours. 2 counties touching, it's an even number. Here we are, even number, you only need 3 colours total. Odd number, 4 colours. Even number, 3 colours. Odd number, 4 colours, unless there are breaks caused by counties that come in at a point, and then you're back to needing 3 colours again. And as far as I can tell, that is all you need to prove the 4-colour theorem. Now, please tell me in the comments if I've made a mistake anywhere. And thanks for watching.